What if I told you that one of the most important ideas behind modern computers was developed more than 1,000 years ago? There were no computers, no electricity, no screens, no internet, just a mathematician sitting in Baghdad, writing instructions on paper. His name was Muhammad ibn Musa al-Khwarizmi. And the strange part, every time your phone follows a set of instructions, every time Google searches for something, every time an app decides what to show you, you're using an idea that has a connection to his work. But how did a mathematician from the medieval world become connected to the technology of the future? Baghdad, more than 1,000 years ago, Around the 9th century, Baghdad was one of the greatest intellectual centers in the world. Scholars traveled there to study mathematics, astronomy, medicine, philosophy, and science. At the heart of this intellectual world was an institution associated with the House of Wisdom. And among the scholars working in this environment was al-Khwarizmi. He wasn't building machines. He wasn't designing computers. He was trying to solve something much more fundamental. How can humans solve difficult mathematical problems systematically? Imagine giving 10 different people the same complicated mathematical problem. One person might solve it quickly. Another might make a mistake. A third might use a completely different method. Al-Khwarizmi's approach was different. Instead of relying entirely on intuition, you could break a problem into specific steps. Follow the steps in the correct order, and eventually, you reach the solution. That concept seems simple today, but it was incredibly powerful, because once a process can be written down, it can potentially be repeated, taught, improved, and eventually performed by something other than a human. The word that changed technology, Centuries later, the Latinized form of al-Khwarizmi's name became associated with a word that now dominates technology: algorithm. An algorithm is essentially a defined procedure for solving a problem or accomplishing a task. Think about a recipe. You don't tell someone, just make a cake. You give them steps. Add this, mix that, heat the oven, wait, remove the cake. That's a simple algorithm. Modern algorithms can be unimaginably more complicated, but the underlying idea is similar. Instructions in a specific sequence. Then came another revolution, But al-Khwarizmi's story doesn't stop with algorithms. His work on mathematics helped spread systematic methods for solving equations. One of his most influential works was devoted to what became known as algebra. And there's something incredible hiding in that word. The word algebra comes from the Arabic term al-Jabr, associated with the title of his work. So think about this. Two words that dominate modern mathematics and computing. Algebra, algorithm. Both are connected to the legacy of the same medieval mathematician. Al-Khwarizmi died centuries before the first electronic computer. But his ideas didn't disappear. Mathematics continued evolving. Then came mechanical calculators, then formal logic, then Boolean algebra, then electrical circuits, then early computing machines, and eventually, the digital computer. The machines changed completely, but one fundamental principle remained. Give a system precise instructions, and it can perform a process repeatedly. In the 19th century, an English mathematician named George Boole developed a mathematical system based on logical values such as true and false. This became known as Boolean algebra, and Boolean logic eventually became incredibly important to digital computing. Why? Because computers can represent information using physical states. On, off, 1, 0, true, false. Billions of these tiny decisions can be combined to perform astonishingly complex operations. But before machines could execute logic, humans had to learn how to express logic mathematically. Now imagine the journey. A medieval scholar writes mathematical procedures on paper. Centuries pass. Mathematicians develop formal logic. Engineers build mechanical calculators. Scientists develop electronics. Transistors are invented. Microprocessors appear. And suddenly, the ancient idea of following precise mathematical procedures is happening billions of times every second inside a tiny piece of silicon. Your smartphone, your laptop, your car, your television, all depend